Good day and welcome to One-on-One Maths Private Tutors. Today we are looking at O-Level and IGCSE Computer Science. The topic is databases. The syllabus requires us to define a single table database from given data storage requirements. We should understand the meaning of fields, records, and validation. We should know basic data types, including text or alphanumeric, character, boolean, integer, real, date, and time. We should also understand the purpose of a primary key and identify a suitable primary key for a given database table. Single table databases. A database is a structured collection of data that allows people to extract information in a way that meets their needs. The data can include text, numbers, pictures, or anything that can be stored in a computer. A single table database contains only one table. Why are databases useful? Databases prevent problems occurring because if any changes or additions are made, it only has to be done once, so data is consistent. Databases also allow the same data to be used by everyone. And data is only stored once in relational databases, which means no data is duplicated. What are databases used for? Databases are used to store information about people, for instance, patients in a hospital or pupils at a school. Databases are also used to store information about things, for instance, cars to be sold or books in a library. Databases are also used to store information about events, for instance, hotel bookings or the results of races. Fields and records are building blocks for any database. Inside a database, data is stored in tables, which consist of many records. Each record consists of several fields. The number of records in a table will vary as new records can be added and deleted from the table as required. The number of fields in a table is fixed, so each record contains the same number of fields. An easy way to remember this is each record is a row in a table and each field is a column in a table. So if we have a table, records are all the rows and each record has a number of fields. So row represents record, field represents column. A table contains data about one type of item or person or event and will be given a meaningful name. For example, a table of patients can be called patient. A table of books can be called book. A table of doctor's appointments can be called appointment. So the name has to be meaningful. Each record within a table contains data about a single item, person, or event. For example, Winnie Singh, a hospital patient, IGCSE Computer Science, a book, 1545 on January 20, an appointment. As every record contains the same number of fields, each field in a record contains a specific piece of information about a single item, person, or event stored in that record. Each field will have a meaningful name to identify the data stored in it. For example, For a hospital patient, the fields would include the patient's first name field called first name, the patient's family name field called family name, the patient's date of admission field called date of admission, the name of the patient's consultant field called consultant, the patient's ward number field called ward number, the patient's bed number field called bed number, and so forth. The patient table structure could look like this. So each record would have a field for first name, a field for family name or surname, a field for date of admission, a field for consultant, a field for ward number, and a field for bed number. For the table called book, the fields could include the title of the book called title, author of the book called author, ISBN number, and so forth. Now we move to validation. The role of validation was discussed in an earlier section. Let's revisit to see the validations we need. Validation is the automated checking by a program that data is reasonable before it is accepted into a computer system. When data is validated by a computer system, if the data is rejected, a message should be output explaining why the data was rejected and another opportunity given to enter the data. There are many different types of validation checks, including range checks, length checks, type checks, presence checks, format checks, and check digits. A range check checks that the value of a number is between an upper value and a lower value. For example, checking that percentage marks are between 0 and 100 inclusive. A length check checks either that the data contains an exact number of characters, for example, that a password must be exactly 8 characters in length, so that passwords with 7 or fewer characters or 9 or more characters would be rejected, or that data entered is a reasonable number of characters. For example, a family name could be between 2 and 30 characters inclusive, so that names with 1 character or 31 or more characters would be rejected. Then there is a type check. A type check checks that the data entered is of a given data type. For example, that the number of brothers or sisters would be an integer or a whole number and not a fraction or plain text. Then we have presence check. A presence check checks to ensure that some data has been entered and the value has not been left blank. For example, an email address for an online transaction must be completed. Then we have a format check, which checks that the characters entered conform to a predefined pattern. For example, when writing a date, we may be asked to start with the date, then month, then year. So this format requires us to write 2 digits for the day, for example, 07, 2 digits for the month, and 4 digits for the year. Other formats may require us to start with the year with 2 digits, the month with 2 digits, and the day with 2 digits. So the year can be 26 for 2026, the month could be 12, and the day could be 13. We continue with validation. some validation checks will be automatically provided by the database management software that is used to construct and maintain the database. Other validation checks need to be set up by the database developer during construction of the database. The practical use of a database management system is strongly recommended for all students. Practical examples will be used in the chapter. The database management software used is Microsoft Access, which comes with Microsoft Office and is used by most schools with students studying for IGCSE and O-level computer science. For example, the date of admission field will automatically be checked by the software to make sure that any data input is a valid date before it can be stored in the patient table. So if you enter a value 99 on the date of admission, a message will pop out saying the value you entered is invalid for this field. So 99 is not a date, and the database management software will validate the date automatically and reject the input. However, the word number field validation needs to be set up to allow only values 1 to 10 to be entered. This task needs to be completed by the database developer before the database is used. So if a number like 67 is placed on the word number, this will be out of range and is rejected. A message, words numbers are 1 to 10, set up by the database developer here before the database is used. And a validation text saying word numbers are 1 to 10, which will be displayed for any error. Let's move to basic data types. There are 6 basic data types that you need to be able to use in a database. These are text or alphanumeric. Text can be names like John, and alphanumeric includes letters of the alphabet and numbers, such as AA 45. That is alphanumeric. Then we have character. Then we have boolean. Then we have integer. Then we have real. Then we have date. Each field will require a data type to be selected. A data type classifies how the data is stored, displayed, and the operations that can be performed on the stored value. For example, a field with an integer data type is stored and displayed as a whole number, and the value stored can be used in calculations such as addition, subtraction, multiplication, and division. These database data types are specified in the syllabus. They are available to use as access data types, but the names Access uses may be different from the terms in the syllabus. So the data types we are supposed to know are text or alphanumeric, description and number of characters, and in Access they are known as short text and long text. Then we have the character data type, which is a single character, such as for male we can say M, for female F. These are short text with a field size of 1. Then we have Boolean. These are one of 2 values, either true or false, 1 or 0, yes or no. In Access, it's yes, no. An integer data type is a whole number. In Access, these are number formatted as fixed with 0 decimal places. Then we have the real data type, which is a decimal number. In Access, there are numbers formatted as decimal. Then we have the date/time. which will give us date or time. In access, it's date/time. Now we move to primary keys. As each record within a table contains data about a single item, person, or event, it is important to be able to uniquely identify this item. In order to reliably identify an item from the data stored about it in a record, there needs to be a field that uniquely identifies the item. This field is called the primary key. A field that is a primary key must contain data values that are never repeated in the table. The primary key can be a field that is already used, provided it is unique. For example, the ISBN in the book table. The patient table would need an extra field for each record, as all of the existing fields could contain repeated data. To create a primary key, we could add a new field to each record. For example, a unique number could be added to each patient's record. The extra field is the primary key field called hospital number. So a primary key is like an ID number, which is unique to a record in the table. Now let's look at typical past exam questions. 5 data types and 5 data samples are shown below. Draw a line to link each data type to the correct data sample. Integer, 2, real, 2.0 since it has a decimal part. Car for character, A. A string is text. Boolean, true or false, so true. Next question. A database property was set up to show the prices of properties for sale and the features of each property. Part of the database is shown below. Give the number of fields that are in each record. Each record has the following fields: property type, brochure, number of bedrooms, number of bathrooms, garden, garage, price. The number of fields is 1, 2, 3, 4, 5, 6, 7. So we have 7 fields for each record. State which field you would use for the primary key. The field that is unique is brochure number. So brochure number is our primary key. Give a reason for choosing this field. It is because it uniquely identifies each property. So the brochure number is not repeated. Unlike number of bedrooms, we have 2 there, 2 there. So this field is not unique to each property. Also, number of bathrooms, we have 2 here, 2 here, 2, 1, 1, 1. So it's not unique. Garden, we have yes, yes, no, no. It's not unique. Garage, we have yes, 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 and no, no, no. So it's not unique. The price can also be the same for each property. Also, the values in the property type are repeating. House here, apartment, apartment. So the values are not unique. Only brochure number has a different value for each property. It uniquely identifies the property and can be used as a primary key. So the only thing that separates each property is the brochure number. So that is our primary key. State the data type you would choose for each of the following fields. Garage. So the only choices for garage are either yes or no. So this is boolean. Number of bedrooms are integers. 4, 2, 1. So those are number of bedrooms. So we can say integer. For price, we use the currency or real data type. Since price is money and is to 2 decimal places. So real and currency are the 2 options we have. Next question. A database, MAX, was set up to record the test results for a class of students. Part of the database is shown below. Give the number of fields that are in each record. Each record, which is each row, has 1, 2, 3, 4, 5, 6, 7 fields. So 7. State which field you would choose for the primary key. The field is class ID. An ID distinguishes each student. They may have the same name, the same marks, but the class ID uniquely identifies a student. So, class ID. Give a reason for choosing this field. It uniquely identifies each student. Next question. A picture gallery owner has decided to set up a database to keep information about the pictures he has for sale. The database table, picture, will contain the following fields: title, artist, description, catalog number, size, that is area in square centimeters, price, arrived, which is date, picture arrived at the gallery, and sold, whether the picture is already sold. State what data type you would choose for each field. Title, we use text. Artist, we also use text, since it's the name of the artist. Description, we describe using text. Catalog number, we can use text or number or alphanumeric. And this catalog number can be automatically generated by the database management software. Size, we use number for the dimensions of the picture. Price, we use currency. Arrived, we use date, since it's a date, so we use date/time. Sold, it's whether the picture is already sold, so it will be a yes/no situation. So this is boolean. State which field you would choose for the primary key. For the primary key, I would choose catalog number. Give a validation check that you can perform on each of these fields. Each validation check must be different. For catalog number, there should be a format in which it is written, so I would choose format check. For example, the catalog number could be in the format letter, 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 and then number, number, number. So we expect something like SQV015. A certain format has to be followed. For the size, I would do a type check to see if numbers are used. For the price, I would do a presence check so that the price has to be written. If the price is not written, the information about the picture will not be recorded in the database. For arrived, we use a date, so I would do a range check. For the month, it's between 01 to 12, since there are 12 months in a year. So if any value is below 1 or above 12, the range check would not pass for the month. For the day, the number of days in a month is from 1 to 31. So if a value is above 31 or below 1, the range check would fail for the date. So those are the validation checks I would take, and the question requires them to be different for each field. Next question. A motorboat hire company decides to set up a database to keep information about boats that are available for hire. The database boat will contain the following fields: boat name, model, engine power, number of seats, life raft, whether there is a life raft kept on the boat, day price, price for a day's hire. Give the data type you would choose for each field. For boat name, I would choose text. For model, I would also choose text. For engine power, I would choose a number, since these measurements are physical. Number of seats, also a number. Life raft, this field requires us to see whether there is a life raft kept on the boat. So it's a yes or no situation, so this is boolean. Day price is currency. State the validation check that you can perform on each of these fields. Each validation check must be different. For boat name, we may carry out a length check, the number of characters to give a name. The model, we may use a presence check to check if it is present, because the model has to be there. The number of seats, we may carry out a range check. So we must know the maximum number of seats that can be accommodated in the boats that we have. For the day price, we can put a type check to see if the format corresponds to a currency. So usually a currency will have a decimal and 2 digits. So a value, a decimal, and 2 digits. Because currencies are calculated to the cent. So that is the type check for currency. Next question. A program will be written to store information about members of a swimming club. The following membership details will be recorded: the name, the gender, the status, senior or junior, the fee, and team member, which is a yes or no situation. Choose a suitable data type for each of the membership details to be recorded. Name, we can use text. Gender, we may use a character or text. We can use M for male, F for female, or text like male or female. A common mistake would be saying since gender has 2 values, we use boolean. But boolean is used only in situations where you require a yes or a no, a true or a false, a 0 or a 1 only. For status, we may use a character or text, such as S for senior and J for junior, or we may write it out completely as senior or junior. For fee, we may use currency or real, since money has decimal places. For team member, since it's a yes or no situation, we use boolean. And with that, we come to the end of the section. Thank you.